Okay, hi everybody. We are going to talk tonight about prime numbers. So a prime number by definition has a couple rules. It has to be greater than 1, and the only factors a prime number has are 1 and itself. So in thinking about that, we're going to go through and figure out all of the prime numbers from 1 to 50. So we're going to cross out numbers that we know are not prime. The first number we're going to cross out, and this throws everyone off, is 1. 1 does not have factors 1 and itself. 1 is only 1, and it isn't greater than 1. So 1 is not a prime number. Then we're going to look at 2. The only factors of 2 are 1 times 2, so 2 is prime. We're going to cross out all of the multiples of 2, however, because they would then have 2 as a factor and couldn't follow our rule. So 4 can't be prime, 6, 8, 10, 12, and you should be noticing a pattern. All the multiples of 2 should be all your even numbers. 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So we're going to look at 3. The only factors of 3 is 1 times 3, so 3 is a prime number. However, any multiples of 3 would not. So 3 times 1 is 3, we know that that stays. 3 times 2 is 6, that's already crossed off. 3 times 3 is 9, so 9 cannot be prime. 3 times 4 is 12, it's already crossed off. 3 times 5 is 15, so 15 cannot be prime. 3 times 6 is 18, already crossed off. 3 times 7 is 21, so cross that one off. 3 times 8 is 24, it's already crossed off. 3 times 9 is 27, so we're going to cross that one off. 3 times 10 is 30, it's already there. 3 times 11 is 33. 3 times 12 is, 36 is already crossed off. 3 times 13 is 39. 3 times 14 should be 42. Oh, already crossed off. 3 times 15 is 45. 3 times 16 is 48. It's already crossed off, and we've run out of multiples of 3. So we're going to go back. We have 4. 4 is already crossed off. We don't actually need to look for multiples of 4, because anything that would be a multiple of, or would have 4 as a factor, would also have 2 as a factor, and we've crossed those out. So then we go to 5. We know 5 is only 1 times 5, so it's prime, but we need to make sure any remaining numbers that have 5 as a factor are crossed off. So we have 10, 15, 20, we need to cross off 25, 30, 35, 40, 45, and 50. Again, for the same reason as 4, we don't need to go through the 6's, because 6 is a multiple of 3, so we've already crossed off anything that would have 6 as a factor. So then let's look at 7. 1 times 7 are the only, 1 and 7 are the only factors of 7, so that number is prime. We then need to look at all others. So 14 is already crossed off, 21 is already crossed off, 28 is already crossed off, 35 is already crossed off, 42 is already crossed off, so we need to cross off 49. So then at that point, we don't need to go through 8 or 9 or 10. We're at the end. Any number that is left not crossed off should be a prime number. And you can go through and double check. So we know 2, 3, and 7. So 11, the only factors are 1 and 11. 13, only 1 and 13. 17, only 1 and 17. 19, only 1 and 19. And so on, to know that these are the numbers that you have left. These are our prime numbers. So we can list, well, these are our prime numbers between 1 and 50. So you could list those out on the side as 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Okay, so now that we have our list of prime numbers between 1 and 50, we are going to look at some patterns. So here I've listed all the prime numbers that we found before on our chart, and I just want you to look at what do you notice. So one of the first things that should stick out is 2 is the only even number listed. So that's definitely something you should notice. You should also look, so if 2 is the only even number, then all the other ones are odd numbers. However, not all odd numbers are prime, so that can't be a rule you follow. You may notice the amounts of 7s, 3s, and 1s that you see. You have a few 9s when looking at the 1 digit. You only have 1 5. So there are not really any rules, but definitely a few patterns. It looks like the numbers are 1, 3, 5, or not 5, sorry. 5 is only itself. Any other number landing in 5 would have a factor as 5. So 1, 3, 7, and possibly 9. Most odd, but again, 2 is not. So just look at these numbers and kind of have an idea of what they look like. Obviously, any red flags, if you see a number that is an even number, you know it's not right. If you see a number ending in 5, you know that that has 5 as a factor, so that would not be right. So this is just going to help you eliminate anything that could be wrong when going through your own list. Remember to double check a prime number. The only factor should be 1 and that number itself. So then the next term we're going to talk about, so this is the final term we're going to talk about tonight, and it's called twin primes. Now, twin primes are 2 prime numbers, we're going to abbreviate numbers, whose difference is 2. So any 2 prime numbers that have a difference of 2. So you'll see 3 and 5 are twin primes, 5 and 7, 11, 13, 17, 19, 29, 31, and 41 and 43. Now I only use the prime numbers up to 50 that we had already discovered. There are obviously more twin primes if you were to keep going. So that's just some more vocabulary to keep in mind. If your book refers to twin primes, that's what it's asking you to do. So finally, your homework for tonight, I would like you to find 3 prime numbers, any prime numbers that we have not listed in tonight's video, and post them on Edmodo. You must be able to prove that they are prime numbers. Otherwise, any questions, please post, and I'll see you in the morning.